Hi, my name is Anthony Rizzo, and today I'm going to be giving my lab report over Physics 2212 Lab 3, Magnetic Field of a Bar Magnet. So the purpose of this lab was to measure the distance dependence of the magnetic field due to a small bar magnet and compare measurements to the distance dependence predicted by the equations for the on and off axis magnetic fields derived from the Biot-Savart law. Additionally, we're going to be using GlowScript to model this scenario. A brief preview of the results includes that the result of the experimental off-axis magnetic field was 6.525 times 10 to the negative 5 teslas, and the result of the GlowScript model was calculated 2.239 times 10 to the negative 5 teslas. So a brief introduction of the fundamentals and physics principles we're going to be using includes that we're modeling the bar magnet as with the magnetic field of a dipole. We're going to be using the Biot-Savart law mainly, like I said, and the next three equations were derived from the lab assignment sheet. So the system for this experiment consists of just a bar magnet on one end of the meter stick, and the surroundings will include then everything else. So the procedure is we're instructed to first adjust the phone vertically and then horizontally with a bar magnet on one end, and we're finding the location where the magnetometer was reading the highest value in the corresponding direction. Once that's found, we then use tape to mark the location of the magnetometer sensor, which is the red X. So yeah, like I said, once the location of the sensor has been found, we then move the phone off axis in the perpendicular direction. And the experimental data we're going to want to collect is the value for dperp and the corresponding value of the magnetic field at that location. So here is the Excel sheet that was provided in the lab documents. So it shows the yellow inputs are the corresponding value of the magnetic field at different distances and is averaged on the right. Those average values are then going to be inputted in creating our logarithmic line graph. And finally, we're going to be inputting values that are going to be then adjusted by the magnetic field due to the Earth, and we're going to get our final value of B net on the far right. So for the calculations, we're going to be using the top two derived equations. We're going to set them equal in order to find what we need to calculate mu. So next we're going to be using our equation from the graph to find our values of n and k. We're assuming here that r is equal to 1 meter. Finally, now that we have all of our values, we can solve for mu, which is 1.92. So getting into the GlowScript code, you can see here we're setting up our physical constants and creating the magnet at the origin. So we inputted that value we found for mu, and then we're going to create that function for the magnetic field at the bottom. Next, we're going to be creating a total of 6 arrows, 2 of which are going to represent the magnetic field on axis, and then the other 4 are going to be perpendicularly off axis. So here we're going to be doing a visualization of the magnetic field, and we're going to be creating a 45-degree off axis point. And finally here, this is the actual model that was created when we run the program, and you're going to see in the top right the value calculated for the magnetic field, so 2.239 times 10 to the negative 5 teslas. So some of the observations that I made, like I stated before, it was the difference in the experimental magnetic field and the calculated GlowScript model. So some of the potential sources of error here could include the failure to locate the exact location of the sensor on the phone, which would cause some errors in the measured distances. And if the phone was not properly aligned with magnetic north during this, the results could have been also skewed. So for the discussion questions, which we were asked to answer, the only ones that applied here were numbers 1 and 4. For the what if questions, so what if you hadn't oriented your experiment to compensate for magnetic north, had instead laid out your meter stick at some intermediate angle? So this would have skewed the data because we would have had to compensate for the magnetic field due to Earth in another way. So we would have had to rearrange how we conducted the experiment. What if you were to stick 2 identical magnets together end to end and run the experiment again? Basically, we would expect our result to be multiplied by close to 2 or at least some kind of scalar value. So in conclusion, bar magnets can be used to model magnetic dipoles. The Biot-Savart law paired with using distance dependencies yields a relatively accurate results when determining the magnetic field. And finally, accurately measuring distance and maintaining alignment with the Earth's magnetic north are extremely important for obtaining accurate results, as we could see in this experiment. Thank you.